Hi, welcome everyone to the next session. So today is the second question of kinetics, and we'll be doing this question where it touches on pseudo first order reaction, as well as half-life. So over here, let's take a look. In a study of the kinetics for the formation of 1 bromopropane, 1 mole per dm cube of propanol, and 0.1 mole per dm cube of hydrogen bromide was used, and the half-life was determined to be 5 minutes. So both are the reactants. So once you look at the values of the concentration, you should notice something. The concentration of propanol is 10 times of that of hydrogen bromide. So this tells us that propanol is in large excess. In general, how do we know when the concentration of one reactant is about 6 to 10 times more of the other reactant? In this case, usually we have one of the reactant, the one of course that has a greater concentration is in large excess. However, most of the time, in most of the questions, you will see 10 times. So it'll be a very clear indicator. Okay? Of course, if it's more than 10 times, then it's definitely in large excess. Okay, so over here in this reaction, half-life was determined to be 5 minutes. And the rate law is known to be rate equals to K times concentration of propanol times concentration of HBr. So over here, since we know that propanol is in large excess, so once you see this, you should recognize that you have a pseudo first order reaction. Okay, what is a pseudo first order reaction? Pseudo, as you know, means fake. So meaning that this is a fake first order reaction. Why do we say so? Because when one of the reactants is in large excess, this rate equation over here isn't exactly right. So when propanol is in huge excess, we can say that rate equals to K prime times concentration of HBr, where my K prime equals to K, the rate constant, multiplied by the concentration of propanol. Why can I say this? It is because my concentration of propanol is so high such that even though it's used up in the reaction, that amount that's used up is negligible. So what do I mean? Let me do an ICE table to explain. So I have 1 mole per dm cube of propanol and 0.1 mole per dm cube of HBr. At first initial, I have no products. Then I have a change, I have a reaction. So over here, looking at this, I know that HBr is my limiting reagent. And since they react in a 1:1 ratio, it means that I will use up 0.1 mole per dm cube of each reactant and produce 0.1 mole per dm cube of each product. So over here, at equilibrium, please take a look at the concentration of CH3, CH2, CH2OH propanol. The concentration is 0.9 mole per dm cube, which is about the same as 1 mole per dm cube. Therefore, we say that it remains relatively constant. So since it remains relatively constant, we can group it together with the rate constant K. So this is why we can write it this way, in this rate equation. So this is known as a pseudo first order reaction because at first glance it looks like a first order reaction, but in actual fact it is not because it is actually second order, right? Just that it looks like it's first order because you have your propanol in large excess. So once we've established this, let's take a look at the link between half-life and first order reactions. So they ask you which is the correct value of half-life when the experiment was repeated separately using the following concentrations. So what is half-life affected by? If it's a pseudo first order reaction, it works on the same logic as a first order reaction. So do you all remember this equation? Half-life equals to log 2 over K. This is for first order reactions. So since it's for pseudo first order, I have to make a little bit of a change. So half-life equals ln 2 over K prime, where K prime equals to K times concentration of propanol. Right? So can you see here? From here, we can tell that what affects the half-life? Only the concentration of propanol, not the concentration of HBr. So then with that, we can properly analyze the question. So the first change in condition is when I have 2 mole per dm cube of propanol and 0.1 mole per dm cube of hydrogen bromide. So what happened to propanol? It doubled. Increased from 1 mole per dm cube to 2 mole per dm cube. And HBr concentration remained the same. So when my concentration of propanol doubles, you take a look at this equation. How will the half-life change? It will reduce by 2, because from the equation, since the concentration of propanol is the denominator, you can tell the half-life is inversely proportional to the concentration of propanol. Therefore, when the concentration of propanol doubles, the half-life will half. So therefore, half-life will be 5 minutes originally, then now I divide it by 2. So 2.5 minutes. So immediately I cancel out C and D. Next, 1 mole per dm cube of propanol and 0.05 mole per dm cube of hydrogen bromide. So concentration of propanol remains the same. Okay, so this is constant. And concentration of HBr, what happened to it? It decreased by 2 times, so meaning it halved. Okay, however, looking at the equation, you can see that the concentration of HBr has no effect on the half-life. Therefore, the half-life should still be 5 minutes. So therefore, the answer for this is A. In addition to this, I would like to introduce just one more piece of information. So for pseudo first order reaction, the first situation is when you have one of the reactants in excess. The second situation whereby you can have a pseudo first order reaction is when you have a catalyst. Okay, so your catalyst will not be counted. Therefore, it is a pseudo first order reaction. Thank you, and I hope that this is useful for you and your revision. Please continue to follow us and look at our solutions every day. Thank you and have a nice day.